是你们那个 PPT 你需要在这上面讲，想在这上面讲。
我有通知吧？
讲的话，一会儿休息的时候你可以讲讲，我到完的时候。在这待多长时间？我这一上午。这个是那个。
没事，这个可以灵活一点。那个，这个也有是吧？啊，
老师那个也能看。
这个也能看。So, good morning, everyone. Today is the last lecture day of this workshop. And let's welcome Dr. Jin Guifei to give us the lecture, which the title is Practice of Innovation and the Development of Beidou Industry. Thank you.
Okay. Good morning. My name is Guifei Jin, worked in Beihai University. The professor in Research Institute of Frontier Science. Before this institute initiated another institute named the Beidou Institute for the Belt and the Road. Now, because of the reorganization of the sciences in Beihai University, we belong to Research Institute of Frontier Science in this university. Before I moved to Beihai University, I worked in the Ministry of Science and Technology of China for 20 years. So I just want to give some introduction about experience in China for technology innovation, the industry development in China. I think during this period, you all know Beidou is newcomer in this family. We have colleagues from GPS, GLONASS, Galileo, and QZSS, also the navigation system from India. As a newcomer in this family, Beidou need to think about how we do some innovation in technology for the applications. Before we introduce the Beidou system into our applications in China, numbers of Chinese companies, not only Chinese companies, but also the international companies like Tribor, like Gami, companies from America, from Japan, from Europe. They have developed their business in China for nearly 15 or 16 years from 1994. So Beidou system need to think about how to face the challenges from the mature business platform GPS governance. So we discussed how we can do some technology innovation and also some innovation in the business development of Beidou in China. And then we hope we can introduce these successful stories, successful applications and development to a global scale. So today I just want to introduce some practice, successful stories of innovation and development of Beidou's industry in China, and also we collaborated in global scale. So this is some brief introduction about my lecture. This is the outline of my lecture. I know from the agenda of this workshop, some colleagues from China give you lectures about the development of Beidou, the development of applications of Beidou in China, in global. First, I want to introduce the family of global PNT, about DSS, about Beidou. I just want to show how we initial the different area about the scenario of Beidou when they began to work in the service in this family. This is the first step. Only we know the scenario about the Beidou faced when they began to work in the service of GSS in global. Then we can find how about the issues we can do some innovation, and we can provide different service or provide different functions to fulfill the requirement from users. So this is, I don't want to repeat the introduction from the former lectures. I just want to introduce how we can find the questions, and then how we worked in to success the innovation. GSS and PNT. This is to show for from the first constellation GPS to see how we can succeed to calculate the accurate position, and then we succeed the navigation. This is I think you are familiar about the architecture of the constellation, so I just go ahead. But this is the general architecture about the composition of the GSS family and its applications. First is the space segment, different constellations provide different service for position and timing. And then we have the ground segment. From the ground segment, we can find some space for the innovation. First is augmentation system. Augmentation system, here you can see the accuracy is 1 meter. This is just generally provided by the ground-based augmentation system, by the satellite-based augmentation system from the world, like WAS, EGNOS, SDCM, GEGEN, and Beidou. But nowadays, we can see we have the augmentation system operating nowadays in a global scale from different countries, Europe, United States, Japan, India, China. But because we are facing the requirement or the challenges from some new technology, like the autonomous driving, so we need to think about how we can provide more accuracy from this operating system. It's 1 meter, but nowadays we achieved 20 centimeter. This is a 0.2 meter. So this is the area of the innovation. From this innovation, we need to think about how about new requirements or some new applications. This is one. Second is for the indoor. Indoor is we sit here, but we cannot receive the signal from constellations. Use receivers, terminals, or smartphone. How we can solve this problem from the different application requirement, different users. Totally, there are more than or nearly 80%, 80%. This percentage is 4 times than the outdoor environment users. So this is, I think, nowadays we discussed about the GSS industry, but the more space come from here is the indoor location system. This is 4 times than today's revenue from these applications. So that's why we discussed about the seamless navigation from outdoor to indoor and indoor to outdoor. So this is another direction for the innovation. Nowadays, I think maybe in the world, we cannot find a vital or a crucial solution for the indoor navigation. We use numbers of methods to achieve this result or to achieve this target. Like Wi-Fi, like a beacon. This ultra wideband. This is from the telecommunication, like the 4th generation of 5th generation telecommunication, TDOFN. So different method to the hope to succeed this location and be the main method to achieve this target. But nowadays, we haven't succeeded this. I don't know if the 5th generation telecommunication can achieve this. I don't know. But nowadays, we have to use different methods to achieve the indoor location system. Maybe, I think maybe after 5 or 6 years, we can find some solutions to unify different methods to like telecommunication system. We can build or establish an indoor location system in the world. But nowadays we haven't. But outdoor, because here, outdoor we have the constellation, but indoor we haven't have one unified system. This is the hot topic in the world. I think maybe every university or every institute worked in the navigation or PNT area, they do this work. Here you can see the accuracy is 2 meters. But for the outdoor or the open environment nowadays, using the augmented solutions, we can achieve the 20 centimeter. But for indoor, nowadays, we can only achieve the 2 meter. So we have a long distance to achieve the seamless and the same accuracy service in the world. This is second. Third one is the receivers. Traditionally or originally, the GPS or GLONASS give us a very, very large terminals installed in the car, in the trucks. But nowadays, we mainly use a smartphone. I don't know if you see applications of navigation. Because, yeah. Nowadays, we mainly use a smartphone for this service. Nowadays, we cannot find some traditional terminals or receivers for the civil, or especially for personal navigation service. But in the future, maybe the main part of the receivers is only chipset. It's just embedded with the other equipment. Maybe it's the main part of the component of Internet of Things, but it's only provide some maybe a database or through the protocol to embed it in the Internet of Things. So for the terminals receivers, it's also on the road for the evolution. Sorry. For the applications and the service, it's the fourth changing area for the innovation and industry. We can think before for the navigation or the tracking or positioning in some photometric or the geodetic related areas. But nowadays, it's begun to be used for some personal application or personal navigation service. In the future, because of the digital twin in the city or in the building or in some manufacturer, it's changed everything. Maybe each digital data is based on the timing, on the navigation. So this is another concept of the digital twin. And it belongs, or it's give more contribution to the digital society. So nowadays, this is fifth, and this is the most important innovation area for applications and service. Maybe in the future, everything we need to get protocol support from GNSS. So this, I just want to introduce, nowadays we are facing the same architecture of this GNSS family. But each component of this family, we are facing new challenges from the users, especially from the digital society, from the ITC development. Nowadays, we discuss about the fifth generation or sixth generation communication, and we discuss about Starlink constellation. This is a low Earth orbit constellation for telecommunication from satellite. So this a new technology brings new challenges or new requirements or new space for the innovation and challenges from to GNSS. It's the constellations, the system of the satellite navigation, different constellations here. The global, regional augmentation. I think before some colleagues give a lecture. And here we just say, from this figure, we can see more than 100 view satellites from the orbit to give service to the Earth. We can say it's too much satellite right in orbit. We don't need more. Don't need more. The most important are the challenges from the applications. Nowadays, it's 100 satellites from the Mu constellation give service, but we do the service to the users only have the coverage for the outdoor or the open air environment is only 20%. From this open environment, we can only provide a service to almost only 30% from some analysis. Only 30% can fulfill the requirement from the users. So this we can say we have compared with the applications. We have too much satellites. So the most important is applications and industry. Why? From the coverage, we cannot succeed for the indoor navigation. So this is the answer. But for the applications, why? For the environment, open air environment, why we cannot succeed for all of these applications? It's because of the broadcast mechanic from the GNSS. This means the satellite broadcasts the signal to the Earth, and the receivers got the signal from the satellite, and they using some algorithm, we got the result of the prediction. This is the chain of the navigation and the positioning. But this is not enough for applications because the provider cannot know or cannot evaluate the performance of this receiver or this terminal because they cannot get the feedback from the receivers to show them the result of the performance. So this is only one way to broadcast from the GNSS satellite. The provider cannot get the feedback or cannot get return to tell the center how about receivers to get the result from the signal. It's operating or it's not. So this because of this mechanical or architecture of the GNSS broadcast. So this brings us a very, very difficult problems. This is because this is initiated by the colleagues from GPS. Maybe from 1920s, because of the capacity of the satellite, they have to use this architecture only broadcast. They have no more power to light the receiver to give the return for the performance. So this is only one way. For the another way, this GPS colleagues deleted. But for the knowledge while fishing, the industry or the development in the business direction. So this is say make some mistake and like newcomers or like some sorry like newcomers as Beidou or QGIS or Galileo, we have to copy it. We know this mistake, but we have to copy this the similar mistake. So this is we just show this. We have too many satellites, but we cannot fulfill the requirement for the users, even in the open environment. So the agenda from the first satellite in the navigation orbit, 1970s. This is GLONASS, this is Galileo, this is Beidou QGIS. This is satellite from India, calling it. But nowadays we haven't solved the problem. Maybe in the future. So that's why from GPS or from PNG office of the United States, they hope they can integrate or introduce the low orbit like the Iridium constellation to collaborate with GPS system. This is, I think, some maybe the very vital innovation point, the applications of GSS area. We don't know how we can find the next level to solve this one-way broadcast mistake in the future. Maybe 5 years, maybe 6 years, I don't know. But nowadays, we all, from almost every constellations now initiated the next generation constellation, GPS 3, nowadays GPS 3, but maybe next day GPS 4. Beidou 3. And we also integrated Beidou 4. The Galileo G2, the Galileo second generation, also created. And the similar from GLONASS. And nowadays, I think we all realized the mistake. We have to solve this problem. So from my personal suggestion, I think if you, when you go back to your country, I think you are already the expert in this area. If your country want to do some the establishment of the constellation or the satellite system, I hope you can realize this problem or this mistake. And from the very early start point of your design of your constellation, hope you can think about not only broadcast, but you must let your constellation have the function for the return. So this is a broadcast and return. Then you can do maybe almost every applications from the open environment. So this is my personal sense. This is a Beidou system. Nowadays we operated the third generation. This is nowadays we can see this is the steps or the roadmap. We have two worked in this way in China. So you can see from here, the first satellite launched in 1994, but the concept originated from the 1983. From 1983, that is China's first satellite launched to the orbit, Dongbaohong 1. It's only 10 years. It's 1970, 73, 74. The 1983, we initiated the navigation system. But nowadays, we haven't the enough power or enough capacity of the to like today's satellite parameters. So we have to think about some new method. So we have to use this active service. How about active? We all know if we want to calculate the location or critical location in the Earth, 3 satellite is the least number of completion. But we only have the national or the manufacturer capacity in China for 2 satellites. So we have to use the Earth the Earth as one satellite. So Earth satellite, and we launched two communicate satellites. So we have three satellites. So that's we have to use a master control center located in China to calculate the digital elevation model (DEM) model to service to the two satellites. So this we call active. Why is active? If you want to know your position, use our China's first video system, you have to call the master control center, and then master control give you the parameter of the DM, and they use the DM and the two communication satellites to calculate the communications. This is other one. This is different GPS. The most important nowadays, we also used this model even nowadays. It's very, very useful for some urgent management like the disaster, like the flooding. We need to know everyone where, how about the scenario happened in the disaster regions. And we need to coordinate for the rescue, search, and logistic, everything, medicine, anything. So this is active. It's very, very useful. Second is the regional passing. And then we have the global system. So this is figures to show the constellation of the beta system. I think you are familiar. This is the service text from the beta system, open and free. It's authorized. This is augmentation. This is news search and rescue. Similar compared with it from Galileo. And this is the innovation from a beta system, the short message. It's like singular and use the smartphone to succeed this function. I don't know if this can operate it outside China or some abroad areas, but in China, it's very useful for the also for some apartment management. I can show you some applications later. This is last year, President Xi announced the operation of the constellation of Beidou 3 for the global service. I just came back from another conference we call International Summit of Beidou in Hunan province. It's started from yesterday and also continued today. I gave two lectures in the summit. Nowadays, we discussed how we can promote the large-scale applications in China, just like this. Large scale means hope every ministry, every department, or every field in China can use Beidou as a reference in the timing and the prediction. We hope we can provide or initial the digital twin based on the timing and location scheme. So this is the topic of the summit. This is the preview to show the achievement about the equipment of the beta system. I think you're familiar. This is chip side receivers terminals. From this picture, I just want to show you. You are familiar to this one, I think. The chipset, the receivers, and the some application softwares. This is document. You're familiar from this. You are familiar with this, so you're familiar for the today's industry scenario of GNSS. This is studied from the operation of the GPS and the GLONASS. But nowadays, we have too many satellites operating in orbit. Why can we think about another generation or another stage of the GNSS industry? We all use the computer, the smartphone. But think about 20 years or 30 years ago in China, I don't know the situation or status in your country, but in China, 30 years ago, it's 1990s, just like this. I studied in Peking University. I just the sales or help the colleagues to do business to buy and sell the equipment, computer, notebook, and for the chip side, for the storage, everything. At that time, the main part of the industry is the equipment manufacture and sales. This is that is the main part. How about nowadays? Nowadays, the manufacture of notebook or the smartphone, even smartphone, the PC, no PC. I don't think nowadays we're facing PC. That is a traditional one. They traditional. They have less challenges. So this is maybe we forget about that. This is just belongs to some traditional manufacturer. Nowadays we think about innovation for the digital twin, for the sixth generation, and for the integration from the constellation, GPS, navigation, telecommunication, everything. We think about this. We think about how we can do some new business in the digital society. This is another stage of the IT business. How about our GNSS? We should learn from the lessons of the development of the IT. The IT for the telecommunication, first generation, second generation, third, fourth, fifth, sixth. How about the GNSS? We see here GNSS Beidou technology at the industry. Why we think about GNSS? GNSS first generation of the industry, the second generation of the industry. Nowadays, we are also finishing stage of the equipment manufacture. So this just we compared with IT. We just on the road of the 1990s IT industry stage. So this is the difference. I just want to, from this picture, I just want to, I hope you can understand. My idea is from here, we need to think how we can pass this stage to light the industry to succeed next stage of the applications and service, just like today's IT industry. Is the statistic of the industry GNSS and the service in China from 6 to 19. By Donghang Li, we are colleagues. Each year, Professor Donghang Li, they compile their group compile the white paper of business in China. This is from 6 to 19. And from this figure, you can see the percentage of the development. It's very, very fast. This is to the texture from China. Different area have different skill of the GX business. The largest is not Beijing, not here. The capital is here, but the capital of GSS industry in China is in Canton, in Guangdong. The most part of the equipment is board, the chip side, receivers from here. This is Shanghai. Shanghai mainly for the service, data, software. It's in the middle of China, like Wuhan, Hubei province. It's just the first state reported the pandemic in China. It's in the middle of China, mainly for the innovation, for the idea, for the algorithm, for the first pilot product is from here. If we want to search or want to study some scientific or technology issues, you can go to here, in the middle of China, Wuhan University. The west part is Sichuan, Chengdu, or Chongqing. I think I don't know if you familiar with Chinese areas. This is Chongqing, Chengdu. It's very special in China. It's very special, and the cushion is very spicy. Second here is one main part of the industry in China. This the fifth, 1, 2, 3, 4. This the 5 regions. Nowadays we support the development of the GSS industry, and each part of each side of the areas have different stage or different team part in this industry. This is the PD family. From this the global family, I hope you can understand. I introduced the family, but I hope you can understand. I just introduced from the different direction to think about the global family, the shortage, or some innovation space, or how it shows us the shortage nowadays we're facing. Why organization system? I think this you are familiar from the former lecture. Let's go faster. So this is the different accuracy from the different system, from constellation, from augmentation. The yellow point is the actual position result constellation. I don't know if it's clear. So you can see here the red point, the red point. Also here the red point is called the lead navigation. It's sorry, here. But the lead point is augmented system. So that's why we use the augmented system for the new requirement of the application, new users of the CSS technology. This one is just to light the users from the out-driving areas have the confidence to think about Beidou or GSS can give some very, very useful support, and they can introduce this new technology to their driving system. Because we succeed this lane navigation, And also the users from the auto driving, they want to use GNSS to support the auto driving. So this gives us a very, very, I think maybe it's not called the most, it's more difficult issues to light or GNSS think about how we can provide the high performance navigation to the auto driving. Performance is another requirement from the auto driving. This means the two-way. One is the broadcast, and second, the return to tell the car how about the performance. So this is need to think about the new architecture of the GNSS communication. This is the first one. Second one is see here is only have some the tree. It's very very just it's very small the scale. But if in some how to say if the tree is covered only all of the lane, you cannot see sky, no sky, and also no constellations, no satellite GNSS. So need to think about how you can provide the high performance service to auto driving in that area. And also this have only the low buildings, just a very, very large distance from the road. But if in some like CBD, the business district, it's large, it's maybe 100 the building meters. How you can succeed the service of high performance? Sure, you have the two way to test or detect the performance, but in some special environment, it's not special. In some urban areas, almost most part of the regions have this environment. How you can succeed everywhere? Australia operated very, very fluently, successful. So this gives us GNSS very, very important and difficult issue. Nowadays, we need to think about this. But nowadays, I can tell you, frankly, we haven't found a solution. This is the architecture to succeed the augmentation. I don't want to repeat this. I think formally you got this. This reference stations is very important to provide the model to differentiate your signal. So this is the architectures in China for province or national level. It's in Xinjiang, it's in Guangdong province, Sichuan, Hubei side. So here just all of these courses or systems is established or promoted by Professor Sichuan, my colleague in Sin University. Nowadays, this is a national GNSS course station in China. It's called China Ground-Based Assessing Positioning System in China. It's operated by China North Industry Group. And also you can find the service from the internet. We call it the Qianxun. I don't know the English name, but in China it's Qianxun. The headquarters of this company located in Shanghai. It's operated. This system operated by China North Industry, and the Qianxun company operated the business service using the similar system of this Chinese ground-based system. This is supported by my university, Professor Shi Chuang, just do the processing and the broadcast system, software, hardware. And then now this system can provide different service like accuracy of 1 meter, 0.5 meter is 1 centimeter. This is the static service. From this one is a dynamic, real-time service. This is a test of China Beidou satellite-based operating system. Nowadays, we just do some tests. We haven't announced the operation service of China SBUS system. And see here, we got a very, very good result. We got the delay is 7 seconds. Is can fulfill requirement of from the international standard, and the accuracy is better than mine. So it's very, very good. And also, the augmented system could be a business model, but it's very important. But this one is verticals. This is the software. And this is the two companies from Europe and United States. And this one is from China. They call it the China CM. I don't know CM is a centimeter or is the China's something. But it gives the name of the China CM. In Chinese, is China. This 中国 is China. 精度 means accuracy. This Chinese name of this augmented system operating by only strong company. So this show you a very, very good example. You can say the augmentation system could be a business pattern. So we call the GSS industry. If you go back to your country, if you want to do some augmented system, it's a very, very good model. It's it's also have the mutual business model for operating of system, and also for the manufacturer of the equipment, and also for the service of the applications. Receivers. This is just the receivers in the 2005, just before 2005. This is different personal devices. This one, this one. I don't know if you familiar about this, but when I worked in the Ministry of Science and Technology of China, this one is installed in the car. It's maybe it's 20,000, like 3,000 US dollar, just like this. But from 2007, it's a very, very the gigantic change. It's very, very like earthquake in the business. Smartphone is initial in China, and everything of the navigation is moved to this one, and this disappeared only 2 years. Only 2 years. You cannot imagine. At that time, some companies like in China, like the Navistar, like the school, I don't know, the Unity, like Unistrong, like 5 or 6 very, very big Chinese companies. Each year, each company, they have the revenue from these personal devices, like 40 million US dollar, 40 million US dollar. But it's disappeared only 2 years. Everything disappeared. It's died like this. It's smart. So it's you can see that we have this branch, have 200 people to do business in this equipment for the sales, manufacture, applications. But everything disappeared. How, so this employees. So this is very brings very large problems. This is the vision. This is this is life. This will change everything. Change everything. Even nowadays, we need to think about the Internet of Things. For this one, for the personal skill, for this one, from the very start of 1994, when GPS receivers uh, uh, imported into China, we have the statistic in 2001. From 1994 to 2001, in China, we have these devices nearly 30 million for this. But from 2007 to 2009, it's 3 years, 7, 8, and 9. We have these receivers like 200 million, 200. So this is why the business of the smartphone applications is developed too fast. For this one, have two large numbers. And the second, because of two large numbers and too many apps created by driven by this. So this is the business, this is the industry, this industry. So nowadays, we think we need to take care about the Internet of Things. This for smartphones in the world, we only have 7 billion, 7 billion. But how about the Internet of Things? For the chips, like GSS chips, I think we can imagine the number of the chipset is maybe 1 trillion. So this is the business. Let's have another story. So that's why we think about the innovation. Innovation is not an innovation from the technology. It's a technology and business. It's technology and applications, innovation and industry. So this when you think about the change of the equipment, this is a maritime, but nowadays it's changed. How to say this is maybe have little change because this is a very long distance from the line, the continent. They just operating in the marine thing. So they change later. This is some new equipment for like this autonomous driving. It's a service for vehicles. You see, it's have another pattern of this. For this one is some wearable equipment. This is if you use a Huawei watch, the Apple watch, just like this one. So this is the first part of about GSS, Beidou. From this one, I just want to show you from this, we think about the family and the development of the signal and the receivers, but also we can learn from the changes of the constellation and equipment. You can see maybe in the future we need to bring some more fast and more larger changes from this technology, and then we can initiate or succeed new business, new technology, new industry. So next, I just want to introduce some initial experience in China, 2 to 2, 3, 4. Break. No coffee. It's water break.
Minutes break.
10 minutes. Thank you. To change the views to the application of GSS. Anything. The second is based on the analysis about the shortage or some new innovation space of the GSS. We have done some pilot product, some innovation programs in China. Use some examples. First is the specific applications of data. Mainly, it's a shortage. So this is the application of GSS area, different areas like civil and lighting, the facility management, fishery, it's logistics, traffic. It's just to show the status of the application using different terminals. See, this is terminals, Gamio, Trigger. And this is a very different terminal. Beidou. This is the terminal can receive the location message and also can return using the short message channel to send it to the headquarters at the control center, know the status and send the command for next stage activities. See, why specific? Just here for the short message service. You can imagine just 20 years ago, it's the second or the first stage Beidou, we have this function, short message. For the mail side, started from the 2002 from the Galileo. A short message can use also for search and rescue, have the different advantage compared with this service, this pattern. This we call the navigation and the short message. We can use this one together. It's a very good application of provide the advanced technologies, especially in the some urgent management disaster relief. Nowadays, the GPS and the QZSS from Japan, they also announced they want to introduce the short message channel into their constellation. This, I think this may be a new function generally provided by the constellations besides the MEOSA. The first one, maybe the third one is short message service. The model of this application is like this one. First is monitoring. Different areas can use this technology, provide the result to the command center or control center to let the control center know the situations in situ result. Second is using the short message can report is different status always need report to the control center, and then for the broadcast, this is a command function from the constellation, and then commanding. Commanding is important, especially for some search and rescue and flooding and disaster, or the some urgent event happened. So commanding is very, very important. Just like this pandemic period, we can understand for this channel is very, very useful for some urgent event happen. Based on this technology, China established the search and the rescue systems in different areas for the marine fishery. When the typhoon or some urgent forecast can be received by obviously it's land or it's very near, so it's boat. But for the large distance, they always cannot receive the message of the typhoon forecast information. But using this technology, the fishery can receive the message for the alerting, and also they know where they can go to use short time to save their life. So this is the commanding systems using in the marine fishery. The second is the earth search and rescue operations. I will introduce you some details later. This is the forest fire prevention. In this area, we also have the shortage of the ground telecommunication systems. So we have to use the short message. Flooding, when it happens, always the telecommunication system destroyed. You have to use short message. This is for the snow. It's for the dam water. For this area, always is remote. In the some mountain, we have we haven't good communication, strong communication systems to support the report and the transfer of the message. We have to use this technology. So this is for the ships. In China, over the ships is more than 1 million, and more than 10 million people work in this area. When the typhoon or some atmosphere disaster happens, always we need to communicate to the captain to let them understand how about the route of the typhoon and where they can go to using the shortest time to save the life. This is the system for the Beidou with the boat management and disaster relief system. From this satellite, it's not only navigation, but also we have the communication and can exchange information with different terminals. And then we have different levels management system. For this one is a nation. This one is for the provincial. This one is for the county or it is a village. So this different level of the network. So this can like everybody worked in these ships know the message of the disaster will be happened or where happened, and then they can know how about the response method or response proposal from different levels. Then we can search. We can save more lives. Disasters. It's operated daily in China, especially from May each year, May to October. It's we call the flooding season or the flooding period in China. Almost every year we have these activities. This is for the different disasters, or like the fire. This has some difference scenario compared with Australia, with United States, because in China we have a large scale, but also we have a larger population. Almost everywhere we have people live there, so we cannot let the fair happen freely. This is have different stream. We can let the fair just happened disappeared by itself, but we cannot. We must respond to prone to this forest fair. So every year from May to it's in different region, like in Beijing, from May to November. This is a period, or we call the forest fair provision period in Beijing. This means each person in the forest area, they have the requirement, or they have the mission to help people, each one just maybe from university, to have the forest to this area. You need to scan the barcode to see, oh, I'm Jin, I'm from Beihai University, and I want to into this year for the tour for anything. And then you need to see, oh, I know this, I know this, I know this. Then I promise that I don't use the files, use H, anything, just like this one. Each year, this have some response. This is control center using different like processing colleagues. Aerospace academy, they can introduce some for the processing requirements and applications. This one. And then give to the related people to take response for the preparation activities. So this is the management system. This is earthquake. This show the status happened 2008 in Sichuan province, very near to Chongqing. It's a very large disaster happened there in 2008. At that time, because of the large area that's destroyed by the earthquake, not only telecommunication and also for the electronic powers, for the more than it's almost millions of people. They waiting for the search and rescue, and hundreds of thousand people to survive. So it's very urgent, and because no power, no communication channel, we have to use the Beidou system, like this one, receivers, and to let them using the helicopter to draw them to this in the center of the disaster happened. Because outside people, we don't know the state there, so we have to send them first to the villages, and they send a message to tell us how about the destroyed, how about the disaster status there. Here, this is a disaster happened there in Sichuan. This we cannot realize the disasters there is too serious. This is just got the most immediately after 20 hours. 20 hours. But the, the, the best period to search and rescue the people is 12 hours. So we have to send people there to use a short message and also location to sit outside this region to let the control center know the status and also know how many people need to be sent to this area, how the food or the clothes, anything for the rescue required by this area. So it's very, very useful. This is the remote areas for the monitoring message be sent to the contact center. Here is in the areas of that. We can use this short message technology to transfer back the monitoring parameters like the atmosphere, like the ecosystems, like the wind, anything can send the result to the contact center. So in China, I think most of the scientific monitoring system using this technology, especially some remote areas. This is very special. Not even nowadays, only Beidou system have this function to transfer the message to let the people who like to receive know the condition, this general function of the condition. But only Beidou can let the other people know where you located and can let the other people if you want to search and rescue you using this function. It is very useful for the disaster relief, for the urgent relief, also for the tourists, anything. So this is very specific. I think maybe 2 or 3 years later, some other GSS constellations will have this function. This we call the general applications. Maybe this will happen in the future. So, but today is the specific applications. So knowledge is correct. But the third one is precise location service. First is the signal. Signal is this we call the real time and strength. This is the skill initiated by National Research Council of the United States. So here we do some the applications using the GPS GLONASS for this one. This one means real time. It's not some urgent or some necessary requirement. For the precision, the positioning is required. Maybe like this one, like the geodetic applications. We hope we can go to the millimeter or centimeter, but we don't care if this is use 1 hour, use 30 minutes. We don't care, but we care about the accuracy. What we want to do is to take care about these 2 parameters, accuracy and real time. This is also the requirement from the auto revenue, just like this one. But nowadays, we just achieved from 1 meter, or just like here. Our target is 1 meter to 10 centimeter, and also its second is real time. But nowadays, we just succeeded like here. This is where I worked in the National Remote Sensing Center of Ministry of Science and Technology of China. We just the outdoor-indoor 1 meter position system. We call it Xihe system. This is the applications started from GPS GLONASS for car navigation from 1994. It's familiar. Also, the terminals that is here. We just want to do progress to the smartphone, and from 2011, change from car navigation to person navigation here. We want to do the service using this as a main devices. So this when you think of how we started from these applications. How about the different issues or different innovation requirement from this application? First is for the pedestrian. Pedestrian means it have the different velocity, different speed. This this is maybe 100 kilometers. For this one, it's maybe only 12 or 10 kilometers. It's different. Second is for the environment. For this one, mainly it's open area. It's open environment. You can see the sky. You can see the sunlight. But for the pedestrian, for persons, always worked in the indoor environment like this. Notice, so why we know the percentage is nearly 80%. That's what we need to calculate how about the percentage. This one and this. Second is location-based service. Location-based service is not a new concept by these applications, but as we consider this smartphone as main devices, we need to think about billions of persons will use this technology, and we need to think about another management or coordinating network. So this is different compared with the car. And also for the pedestrian, first accuracy, stride. For the the different speed compared with the car and the person, the stride is 1 meter. So this is just like the Mustang, 1 meter. Second is material positioning. So that's why the social network is, you can imagine, just think about 10 years before, the social network is just like a concept. It's always dreamed by the scientists. But nowadays, it's used everywhere, every day. It's a material position. It means you know my position, and I also know your position. I don't know if you use a WeChat. WeChat has the location, and the location have the function of the sharing location. This initially. Okay. Second is for the information, for the temporary. Temporary is for the real-time information. It's the most valuable. You will pay the money for the information. So this is the new business model. It's a temporary solution of the information. Then the fourth one is the indoor or the city canning for the navigation, just like the business district. We were lucky, which we succeed this from the pilot product supported by National Science and Technology Program. First, for the 1 meter wider. It's the second for the information for terminal. For this one, service provider. This is a new part of the industry chain compared with GPS integrated. So nowadays we call this one. We hope we can have the second generation of GSS industry because we got a very, very good, successful story from here. This I just show you before. This very earlier from 10 years ago, we succeeded in Wuhan for the Beidou PPP method for the lane navigation. And also based on this method or algorithm, we succeed using test GPS, Beidou. This is the dual flexing. This is the single direction. You can see this accuracy for the nose, source for the vertical. Each one we have very, very good for this is 20 centimeter. It's 30 centimeter. The GPS is more better. Beidou. And also this is the indoor. This created by Chinese scientist Professor Deng Zhongliang from Telecommunication University of Beijing. We got 3 meter, but this is succeeded in 2015. For the Wi-Fi, it's meter, but the cost is high. Cost. For the ZigBee RFID, ultra wideband, the broadsheet light. For this one, for the TCY film, we got a very different result, very more better result. So nowadays, change the from TCY film to 5G generation communication system. Nowadays, the international standard using the 5th generation telecommunication system for indoor navigation is led by Deng. This is the prototype of this indoor navigation. See here, have some new equipment, new antennas located in just inside the belly of the campus, the campus of Beijing Telecommunication University. It's right here. It's right here. Yeah. It's too near to Beijing University. And this has the pack like terminal. Here is the monitoring systems showing the operation or changes of the signal. And this is a competition of indoor positioning happened in China in 2018. This Professor Chen Hu is academic university. Before he's the director of the National K Laboratory. He's the leader of the expert team for this indoor navigation in China. We have this happened in Beihang University. It's the main building of Beihang University. We use the indoor navigation, outdoor navigation, and also the park in the bedrooms area to test the indoor, outdoor, indoor, test the different environment. And we have 3 groups. First is smartphone, only smartphone. Second is smartphone with general ITC tools, Wi-Fi, like beacon. Third is a smartphone with low-cost neutrals. This means specific equipment you need to install to support, like the shutdown, like the UW. And the best result we got from this competition is 17 centimeter for indoor. It's a very good result. More than 15 groups from different companies, different institutes, different venue from China participated in this competition. This is show some environment to test this indoor or outdoor. This is just the inside. It's the student Beihang University. It's a parking area. It's just on road from indoor to outdoor to outdoor to indoor environment. This is the shoe. It's in the main building or the indoor environment. This is just a test, even the similar student environment. All of the companies, they know the environment, they know the method 24 hours before. 24 hours before they go into application. So it's a similar standard. It's a similar test environment. You just the operation is by themselves, but the result is reported or recorded by. I think this can show us the actual or real result for Chinese indoor navigation. The first is the PNT for the city augmentation and also indoor environment. The second one is for information. We also initiate a new concept for this area. We call it the comprehensive location map. In Chinese, this is 全息位置地图。全息全 means total, comprehensive. 息 means information, location map. This means we hope we can integrate or compile all types of digital data created by human beings from internet using the location to do analysis, to do overlay. This is the comprehensive location map. This name is created by academic Zhou from the Geographic Institute of Academic Chinese Sciences. Using this new concept, we created hundreds of API different protocols to integrate or to interoperate it with between location and digital data. So this consider the internet is a GX. It's a GX. So this is the different architecture for the development of GX. GX, you know, some of colleagues study GX. No, GX mainly just for the local, but we hope internet. This means 40 billion website can use the geographic data together. So this is another skill, And also we need to think about another systematic algorithm and model for this call. Because of this new concept, and because of we succeed the innovation of this new concept, so the progress is unbelievable. Because of this, so nowadays, China, we use a smartphone to have the location-based requirement in China every day. It's more than 200 billion times. Like Baidu, like Tencent, like Alibaba. The service, each company more than 50 billion times every day. So this is unbelievable. Even we started to sign the contract with Baidu, with Tencent, between ARCC and Baidu and Tencent. We don't realize that this is like this one. It's a surprise. And also, because of this concept, we got unexpected progress for the big data. This is the temporary and the spatial big data, like this one, or the digital map, like the Alibaba, they buy the Gao. I don't know if Chinese name is Gao. Autonomy. I know English name. I think maybe it's autonomy. Uh, the digital map they said 10 billion RMB. It's 1.4 US dollar. One 1.4 billion US dollar to Alibaba. This is also one of the biggest sales activity happened in this area. And also for this POI, point of interested collective channel is I think the biggest in the world. And also this brings new big data service. We always think we need to think about remote sensing, geographic information together with the big data. But we haven't succeeded to the geographic or GSS or GIS together with the ICT society. But this one, we succeed. This is the core and this is the big data. So this is for the data. We have the solutions. We have the success story work together. And another one is for the GSS, for the equipment and Internet of Things. But this just show some holiday of this big data. Like this is travel analysis. This by Baidu. This for the takeout restaurant analysis in Beijing area. Autonomous driving in agriculture. This is from 2015 we succeed in Xinjiang. You studied in Xinjiang areas. But we studied to do pilot project in 2013. It's very difficult because we haven't got a reliable and stable signal from GSS, from GPS, from Beidou. No, we need to have some supported system or accelerated systems, facilities to support this reliable, stable signal to service for this smart driving of this agricultural machine. You know, this agricultural machine is have a very strict accuracy of the horizon. For the vertical, no change, but for the horizon, it's 2 to 5 centimeter. 2 to 5 centimeter. It's more precise compared with auto driving car. It's the agricultural machine. Different agricultural machine, they need to use the similar channel to do everything. This is for the first. Second is seeding. Second is fertilizing. First is for the harvest. Each one they need to use the similar channel to do anything. So it's the accuracy very strict, 2 to 5 centimeter. So we do 3 years to do pilot product supported by Ministry of Science and Technology. And I also remember from the first year for the even for the fighting between our company and with the users, the the, 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 the tractor drivers, they always fight. This is something like boxing. This is how to say always we make mistake, not initiated or created from the manufacturer of the equipment, but from the signal. But from the signal, for the tractor drivers, they cannot reach the centimeter at the control center. They cannot go to the control center. They just fish the person from the company. So they just have the fight with the company. But after the test, in Xinjiang province, we succeeded. Nowadays, I think there are hundreds of thousand machines operated not only in Xinjiang, in Henan province, in northeast of China. This is we got an innovation from algorithm first, and then we got our own chipset, unit strong. I think maybe Dr. Ju Shen give you introduction about this applications. This is for the equipment, board, antenna, radio, and MU. This is virtual unit for the navigation to support when some mistake happened from the satellite signal. We can use this initial channel to support this. So this is another channel to support the GXS using the whole chain to support this process PNT. We succeed. These are the products. Just to show you here. I hope you can understand from the autonomous agriculture machine. We China can support or help with you for the collaboration for the application in your country. The whole chain we can succeed. The second, besides the hardware, and also we have our own software for autonomous driving and navigation. Every software is initiated or written by Chinese scientists. This is a management system using software and hardware. We can have another pattern to manage the full system for the farm frame, for the profit and loss analysis, and for the data management, for the data sharing, for the operation monitoring. Second one is for the operation of the farm in the whole life of that period, like the farm standard, like using UAV to monitor the plant status, and also using the autonomous machine to analyze each team of the tractors or machines. They have the different efficiency. This is fleet healthy. This is otherwise for the service of the harvest or agriculture. You can use this for the feature analysis and for the buy and seal your harvest, and also for the soil information to test for the detect the health situation before, and then you know when and where to use the accurate harvest library for this management. Third one is tourist. Just say, because of short message for the tourist, even for the person or for the machine, for the drivers, you can maybe go some remote areas. You can use the short message to know your own position, and also using the short message channel, you can write the search and rescue control center know your status. If some unexpected or urgent status happened, you can give alert or warning to the control center, to that center, know you are in the emergency, some routine, some SOS, just like this happened. And the control center know your position. They can send the team to your city. This is always to save the lives for the tourists. This happened almost more than 200 times or 200 process in China every year. So this is very useful. For this architecture, this is Beidou, this is a receiver, and this is a platform and control center. And this is a search and rescue team. This team always, I don't know the status in your country, but in China, it's always volunteers. Volunteers. Almost every city, every province have numbers of these volunteers, search and rescue team. They just installed to this control center. If something happened, the control center knows the information and send the message to the search and rescue teams and the rescue teams. They will go to the correct location to search the terrorist. So this is the architecture of all of these search and rescue applications. This platform here, this is Beijing. I don't know, maybe in this in Beijing. This is Beijing. It's just the nose of Beijing for the red one. You can see here is mountain areas. Each year we have numbers of teams of tourists. They just go outside themselves. The nowadays always they take the Beidou short message to the receivers. They can buy these receivers and also they can just rent for this maybe 1 day, maybe 2 days, maybe 1 week. It's very cheap. But for the blue one, sorry, for the green one, for the is correct. It's you can say just the walking along this road, but sorry. But for this blue point, it's just you turn off your receiver. This means you haven't used this receiver. So you can see here, this just this area is just very near to this building. Maybe just the city in the whole. For here, it's just awesome. But for the red one, it just say you give the SOS, give the warning. You don't know what happened, but they just show the routing here. For this one, the contact center, they will send a message to the receiver to tell what happened. And if they got the confirmed or assured message to say, I'm in the urgent status, please help me. Yes, it will send the team to the location there. So this is the monitoring and the response for tourist visitors. This is just to the pilot system inside China. Nowadays, we support the trans-border, the cross-border tourists, like auto driving, like the tourists just go abroad. Also use a similar system. This similar system, we just added like it's the diplomatic communication with the related government. So it's very useful for the tourist visitors and also very useful for China, for even Thailand, for to attract tourists overseas. The fourth is for the guaranteed signal service. This is another issue. This one is for the short message. This one is for the strength, like the smartphone. This one is for the guaranteed signal service. It's guaranteed. It means it's you can do some operational system rely on GNSS signal. This because it's guaranteed, authentic, or reliable, or trust signal. So this means it's commercial service of the signal. Because it's commercial, we got the money from the users. Another one is if some mistake happen, we need to pay back. We need to pay back. So this is another issue for the GIS industry and applications. The Internet Things of Location Network. You can see this Internet of Things. This one, we hope we can integrate the Internet of Things and also the Beidou. But Beidou is just the location label to install into these things. We cannot just think we need to send a terminal, a receiver to this internet. No. We just send the information or protocol from Beidou system to these new ICT facilities. So this is the digital twin. This created by Professor Jie Yako from Wuhan University. Here is the Internet of Things, sensor network, but each network for the sensors, for the phone, no problem, for videos, for the car, for the mobile vehicles, everything, they have the label of the PNT. Label PNT is just a signal compared with the communication signal. So each sensor, they have the label of the temporal and spatial. And then they acquired or be acquired to the cyberspace. So each one, they have, sorry, this is Chinese, have the location label and can be aggregated or integrated as a comprehensive location map. This means the digital map compared with the reality and the virtual area is just a mirror, just a mirror. Each one is so the digital twin nowadays from our GIS society, we just call the digital twin is digital mirror. So this is central network, IoT, and internet. So the digital society, I gave a report in the this year's the Munich summit in this March. I just report my idea about this society. It's a digital mirror of GIS applications, and also Mr. Patrick is a deputy general from European Commission. They also say the digital society using the reference station, reference information from space, from the temporal, from GIS. See, but they have another name of the conference. It's a similar idea, different name, different technology pattern. So this is like Internet of Things using the GIS in the early management. First is using the Beidou and using the IP version 6. This is the address, another one. And also the unified access of different sensors, different devices using the navigation of PNT label. Second one is we have the enough number inside one city. It's billions of nodes. Second one is we using because we have the telecommunication channel and GIS. This means we have the broadcast and then we have the return and we have the unified two systems. So we can build the full coverage and monitoring systems for the operation status. So this is why we call it guaranteed. It's guaranteed. Oh, here is show some like terminals, everything. And here just show this is the bicycle operating out in Beijing. See here different vehicles, different users, different applications. Here is for the fire alarm. let's say here for the facilities of the fire extinguished. Every equipment, they have the not only for the sensors to have the static information like the one, like the environment, everyone, but each one we just embedded the PNT label into these systems. This means it's only added a little protocol standard into these sensors. It's not a new sensors. It's not changed everything. No, it's just added some digital information from PNT label. So it's changed only a little. But because change everything, they have the digital label for the indoor pressure data, for the camera, for the broadcast, for the gas. They can use this information as the digital measure. This is reality, this is what. So this is a change. Using this one, we can do the emergency reporting because everything is a digital measure. So the information can be processed. It's for the online module for the analysis and using the warning pattern or warning model, we can do the early warning. And everyone from this chain, they receive the information for alerting together in the same time. Because this is, we need to think to thank the smartphone. So this is the mobile alarm processing systems. So this is we call the one pack. So everything can be overlapped or integrated in this map. This is a comprehensive location. And this is the interface for everyone, for the login, for the emergency rescue status, for the indoor data, and for the types of different data, and for the alarm list, and also for this emergency data analysis. And for this one, here is the reality work. Here is what we are doing, use the location and with Internet of Things. Here is for the processing. This is for the fire extinguished operation team. Here is for the monitoring, maybe inside the building. For this one, maybe this inside just maybe like in Beijing area, in Beijing municipal government. So, but everyone, they can receive the information almost in the same time. Simultaneously, they receive the information. So everyone can process, can give the idea to process the alarming or the warning together. So this is very, how to say, shortened the process and also the chain to process this disaster. From this one, we think in the future, terminal is only chip side. It's only chip side. No smartphone, no terminals, no devices. It's only chip side. This one is PNT and IoT can integrate. This significantly. This is have done. I RCC supported the pilot project team in 2018, first in Beijing, in Tongxian County. This one to this. For this location here, we need at least 1 meter accuracy for location. If not, we cannot use this because only you parking the bicycle inside this area, it can stop. If not, also you need to pay more. So this means we must give the guaranteed service, guaranteed signal to this system. If not, for this one, they need to maybe to tell the company, oh, pay more, you need to pay back. Too many investors. If everyone has this question, I think this company will liquidate tomorrow. For this smart city, not because smart city. Today, maybe Singapore have the most advanced smart city. But nowadays, we hope we can use this digital measure or digital twin to another state of the smart city. This means the Internet of Things, the location, the cloud edge computing, internet, the big data, everything, artificial intelligence, everything can be integrated into this smart city. But we need to think about it. Not the GIS, the GIS, they haven't this capacity to support smart city. Maybe in the future we can succeed the internet as all GIS. Before we succeed that target, I don't think the smart city can fulfill everyone's imagination. So today, the smart city, every expert, every official, even already present company, even nations have different ideas for smart city. Someone supported this city, say, oh, my city is smart. Someone say, no, it is not smart city, it's only digital. This the tolling system and L3 support. This is the test in China for the freeway to do the tolling. We hope we can destroy every valued tolling point. But nowadays we haven't succeeded. How we can use the Beidou to support the toll system to use the routing for the from the calculation of the each kilometers you need to pay how much you need to pay. Just this is, but nowadays it's very complicated because in China I don't know exactly in your country, but in China we have too many bridges, different levels. We have like in Chongqing, it's in mountain area. We have too many channels, many. See, we call it, this is forbidden, just limited. It's not open environment. It's we call it it's unlimited, unopened. Is for the like indoor environment. We should use another. We call it the closed environment. We cannot got the signal cancellation. We need to think about some other technology systems. Also, for this one, so L5 is our dream, but if this can operated in the cloud, we need to be practical. So nowadays, we hope we can succeed L3 of Australia country. For this one, we need to think about this quality of service. This means the performance needed to be detected and analysis real time. Nowadays, we have only one channel broadcast. Second, we need to establish return channel. And then we need to detect and alert for this quality of service of the terminals real time. So this is the challenge, quality of service. The third one is this one. Data is the biggest because we need to tell or to control the driving autonomously. This means we need to send each kind of the information to this vehicle. So this is why the importance of the comprehensive location map for the like how about the road, how about this turn, how about the anomalous situation before. That's like this one. So the data is most important. And also it needs the status of the route. This is we think about the solution of the one broadcast return two stage of the channel to solve this communication. This is a comprehensive map to support big data for the autonomous driving. So this is the introduction about how about experience in China and how about the idea what we want to do in the future for the innovation and how about we think we need to consider another generation of industry. Some suggest it's a second generation. This the first is initiated by GPS aloneness. This is the main characteristic is the equipment manufacturing. But nowadays, we need to think about the guaranteed signal outdoor indoor. So we need to think about compared with ITC industry, the second journey of GS industry is coming. Here, it will service for internet. GS barcode is just a label inside. And because we have the label, we have the code, we need to create meetings, different protocol to connect with the ITC society. So this is some characteristics of the second generation test. It's very brief for the ubiquitous coverage, for the support control operation, and for the universal application management. For consumers, it's the internet. We need to think about trillions of users. We need to support and control support. For the international cooperation, for this Beihang University in Xuanlu, running here. It's my institute called the Beidou Institute for the Belt and the Road. We have the training activities with partners, different countries. We have to support different countries to establish the cost stations and to do some processing the broadcast pilot product. This is the law. In the action, support different countries. Now we work together with Asian countries to support the Asian ground-based processing processing system. It's a proposal for the collaboration. If you are interested, you can put from this point, you're free to got it. This is the cooperation for the joint lab technology transfer for the GSS and remote sensing systems. It will be maybe 10 or 15 lecture to introduce this Earth observation system for the search, manufacturing equipment, applications, innovations. And this is a million US dollar. This is to start this collaboration, need to think about budget. And this is the kind of product in China. This is a wide area real-time process positioning. This the smart agriculture. This is the tourist. This in smart city, transportation, marine disaster. This is for this one mainly have the target of the operation. This means it's turnkey. We do together with the producers to establish system, and we just turnkey to the people in your country and operated by your own countries and own. So this is just reach the operation. It's not the innovation scientific. This is the business. This manufacture of terminals. This is a joint lab. This is the pilot project. Just I don't want to repeat. I have introduced before. But this is transportation. Oh, summary. Thank you very much for your time. I think nowadays, Beidou, we have the successful pilot product for the indoor, outdoor PNT application. For the mobile internet, I think compared with the colleagues from Europe, we have got a very, very good result. And also, for the next stage of the smart applications in agriculture and tourist, we have got a good experience if you increase it. Nowadays, we have worked in the innovation and that to promote the second generation Beidou GS industry. This means we hope we can consider the applications just inside every area in some specific field. We are willing to cooperate with colleagues. If you have anything, just feel free to contact my email. Thank you.
Okay, thanks for the wonderful lecture. And now comes to the Q&A time. If you have some questions, just raise your hand. Okay. One minute. Yes, do you have questions? That's fine. Okay, so if there is no further questions, that's for today. Okay, thank you for your oral effort. Okay, we have a very nice. Okay, thank you. And short rest, we have a group picture with